I am Rajneesh today. I am software developer. So today we'll discuss about this architecture. So here we are developing the user API. So we add the functionality add, get, update, delete user. Simply we can say the user registration, like we add some user data in database, and after that we do some like data analysis with this user data. Okay, so first of all, what is the cloud? So you can see like this is AWS. So on demand delivery of IT resource over the internet. So basically like we don't require any like server or like physical machines to like deploy any application or develop any application. We can get everything with the help of this AWS, basically with our cloud. Yeah. So AWS have like lots of APIs, like lots of services we can see. There's some analytics services and like application integration services. And there is lots of other compute services and the container. How can like deploy container and how do you manage the container images? So it's like consumer. There customer engagement, like create contact center. So you can create the call center application without like writing the code. We can use the service, everything available here. Database, so we don't require any like physical server or anything. We can create database with all of these services, so like Azure and like dynamodb. There's lots of database services. We create different type of database, like we want to create a relation database, use RDS. If we want to use like create Cassandra, you can use this service. Like KVLP database, you can use dynamodb. So there's multiple services available to create database. So like you want to like MongoDB type database, you can create a document database, Amazon document service you can use. So we can create like MongoDB capability database. We have developer tools like this, the new distribution of the open GDK, the service. We have development, how to develop service and deploy on the cloud. So like build, automate, so we can create the CI/CD pipeline, everything available here inside this product. And if you go down, like this is the storage service, like if you want to store data, so you provide the server, like physical server. We don't require the server there, so over the internet we can use this service and we can save data and we can retrieve data. So this is useful. These are very scale. We can scale the service very high level, like so you have like distributed storage, basically you can say. And this is other service where we can elastic block storage. This is the file systems that so there are multiple services, like let's say archiving, the backup. We want to backup data, we want to archive data. So you can different purpose, we can use the different services for storage. This is a very important part, like security, identity. So we have like so in this product they create this IAM service. So basically this is used for create the roles. So whenever you use any service, if you want to access any other service, AWS service, so you provide the role, then you can access the like if we have like API gateway service, I want to access like Lambda, or we have Lambda service, we want to access DynamoDB or S3, then we have create the roles for DynamoDB and S3, and we have to use this role in LambdaDB. Then Lambda can access DynamoDB and S3. Otherwise, we cannot access. So first we create the like roles. So like okay, here also this all this security like all these service provide the security your application, or we can say this cloud. So your application will secure on the cloud. So the AWS provides there lots of security services, single sign-on. So like here key management services, encryption description, we can use this key service, certificate like SSL DSL certificate issued. So there's a lot of security services. This is very important for security purpose. And this is something new in term technology, like I don't know about more useful service. This is media service, basically content conversion, different format, and so that's basically on like the Netflix use this service too much. Netflix, Hotstar, there are lots of content-based application they can use the service. Media basically. Machine learning purpose, you want to machine learning, you can use these pre-defined services. You don't write too much code, you can use these services. You can do the machine learning. It's not require too much code like IO things, not. So you can provide it Internet of Things product. There are lots of services for IO. So I discuss like all these services. So we have application integration. There we have the queues, messaging queue, topics, and this is the Imagine MQ service, the similar like ActiveMQ, provide the broker for it. So there are all these integration type. Like suppose one application posting data in this SQ, another application can jump this data. So the like integration type between the application. Okay, so all these are the like services that we can use to develop the application and deploy the application. So here compute, this is also very good product. AWS, they provide lots of services. The ec2, here the virtual server in the cloud. So we don't require to, like suppose we want to deploy one application, then we don't require server. Just create the account and you use the service ec2, and you can like set up your server on the internet. So we don't require any physical server. Just to have application, you use the ec2 and deploy your application. Or they already, if you don't want to use this like server anything, we have other thing like Lambda. You create Lambda and you can don't require to create ec2. You can just deploy your application without this Lambda, this serverless deployment basically. So you have logic, you can deploy the code. So this Lambda run your code, the service run your code. So you have just only business logic, you just put there, and there's no need to worry. Similar elastic bean stack, like you have. So here they provide some like platforms like server like Tomcat or other servers where you can deploy your WAR file. You create the WAR file and deploy. Don't create the ec2, and if you create the ec2, you have to set up like Tomcat or any other things in ec2 because this is the only server and you have to do. But here the inbuilt you just only select the platform, like you upload your WAR file, you select the platform like Tomcat or anything you deploy. So you want to use, you can use this service. If you don't want to use ec2, okay. And it's batch processing here. Batch jobs, your job is you can deploy here also without any server. And so the Lambda, so Lambda is very useful, like you don't require like serve all the, just you write your logic and you deploy here. So I will, yeah. So here is about the AWS and what is the cloud. You can see the definition. So there are lots of benefit to use the cloud. Like we don't more think about the infrastructure because infrastructure already available. We only think the business. So like we think only the how to create the applications, and so deal only business. We don't care about the infrastructure, or we don't care about the how to scale infrastructure, how scale up, scale down. We don't do much because we just do a configuration on the cloud and we get everything. So other like similar like AWS, we have the cloud vendor like Azure, so also powerful, and this is the Google Cloud. So these three are major like AWS and Azure and Google Cloud. Almost they provide the similar like services. Yeah. So there are not too much differences. Like maybe the internal processing, like internal logic, maybe may have different, but the like, but whatever service we have here, like yeah, we similar approx like 80% things we get here. Like product, you can open the product, you can see, yeah, this is analytics part. You can see there are lot of analytics things here. Similar, you can go, this is like here product and analytics. So here is the analytics, they are Athena and they are CloudWatch. Okay. So EMR basically you can create sorry, what happened? What? Yeah. So where is analytics? Internet very slow. So what is going on? So I'm discussing about the EMR. So EMR is just without the service, with help of the service, we can create the Hadoop cluster very easily. We like just only put some configuration and the cluster will ready in 5 minutes. We don't require any like machines, servers. We create a Spark jobs, Hadoop jobs like MapReduce or like the Epic, whatever coding you want to write, and just you can deploy a code there. You don't require like infrastructure like to set up the cluster. The cluster is ready if you use this service. They just provide them configuration. Yeah. So similar like here, yeah, Kafka cluster you can create their real time like streaming data. So there are lots of services and for analytics we can use. Yeah, so big one, this is the lake function. So if you want to create data lake, you can use this service. And if you want to do some ETL type work, you can use this like extract, transform, load, and this is very helpful. The similar like SSIS Informatica, that yes. And if you can use this data pipeline, if you want to like for DynamoDB, you want extra data from DynamoDB and load in S3, you can use this service data pipeline. If you want to the S3 to DynamoDB, so here you exchange data between the source, two different source, we can use this data pipeline. Similar here, the service, if suppose somewhere we have some data, so we can like subscribe this data and use in the cloud. Quick site basically the visualize your data, and that's similar like Power BI and Tableau. Yeah, that's not so this similar thing we can find here like for analytics. You can Azure Databricks, the Spark cluster you can create, run your Spark job, and here the Hadoop cluster you can create, and you can run Hadoop job in Storm and other. You can Data Factory similar like AWS Glue. So we have Glue API in analytics part. Yes. Yeah, similarly you can this thing. Yeah. The Data Factory. So machine learning, stream analytics like same the kinesis and the data lake. We have the AWS lake formation. These are the similar data lake storage. Yeah. So they are like providing the similar kind of services. All these three cloud. So it's depend on which one we want to use. So today we will use this AWS to implement this design. We can say this architecture. Okay. So here we have client tab. So any client can use this user API to like add, get, update, delete user basically if want to the term like user registration. So any client app, the client app can be developed in like Angular, Android, iOS, or even though it can be the any like microservices or any maybe it's Lambda the hit this API. So this is anything what I have for the so API gateway basically use to create REST endpoint for this user API. Okay, here we define the add API and get, update, delete. So I'll show this one, and after that create a Lambda. So API gateway can pass data to Lambda. Yeah. So we add some functionality in Lambda to push data in dynamodb and S3. After that we do some analysis with this data whatever available in this file user.txt. We can process this file through Spark job and write the data in hdfs. These are my cluster. So cluster basically whenever you create the cluster with help of this EMR service, the cluster basically run on automatically ec2. So the internally they create like suppose you take 10 node, so 10 ec2 machine like instance we created. Yeah. And so yeah, so here is hdfs you can so Hadoop cluster basically have Hadoop file system to save the data. Yeah, so I will run this one job that read data S3 and load in hdfs. Yeah, and make another job that read data from hdfs and write to S3. So in hdfs I use parquet format, not this text. I will change this here. We use different extension of the file. The parquet file basically used for like useful like take less memory and reading writing fast if you are using parquet in the cluster. And this is the Athena. Basically we can load S3 data. We can query the S3 files. So we have a user report, we can query this file through with Athena. So basically Athena I think use the Hive concept, I'm not sure. So after that we can visualize the data, use the QuickSight basically the service that used for visualization, the AWS service. The similar like the Tableau and Power BI, yeah, or we can develop on web app application to view these reports. So this is very simple like API and data analysis process we can say. So I create this basically learning purpose. Anyone who don't work in AWS cloud or any cloud, they want to understand like how we can develop things on cloud and how to done analytics on the cloud. So this part basically like application part, and this part basically like this big data part. This is like the analysis part. We can create data lake or we can do whatever we want, and this is the visualization part. So yeah, three part, like one application and there's the analysis and visualization part. So also the front end, like here is this is client app. For the client I used Postman. So I already created API gateway. So I created add user API with the post method. So this is a REST API, and I will put this body. Yeah, okay. So I don't have any like client. I use this Postman as a client. Okay. So I talk about this IAM. This is very important service. Basically, this use for create the role. So here like Lambda want to write to the dynamodb and S3. What Lambda cannot write if we don't provide a role, like if not provide access for dynamodb and S3, Lambda cannot write. So we have how to provide the access. We create the role. Okay, and we use this role in Lambda. So I create two role. One like I create a policy, security policy that have two role access. For dynamodb, one is the S3. Okay, similar like here, if you want to access ec2, then we have like S3 to ec2, we have to add role, or so everything like secure. Like here, one service, you access this service to this service is very secure. So we have to provide the role, then we can access. We can enable the security, like provide like some role, then we can access. This Athena can access this S3. If we in S3 we provide access to this Athena service, then Athena can access this S3. Otherwise not. So based on the for which user I want to give access, we can provide the access in S3. We can, yeah. So the CloudWatch basically this CloudWatch like monitor these or log and all the services, AWS services. Okay, let's start the development part. So I will explain how I create this like diagram. I use the this application. So here we can like multiple icon. We can drag and drop here. And we can create this design. So this is very look like it's very nice, like how like you can add the flow and explain the very well. Okay, so you can use the icon here. There are other app also. I use the drive. There are multiple app you can use to create the diagram. Okay. So suppose if you want like this API gateway, okay, then you have to click create API and give this API name and select the protocol, REST or whatever you want, and then you this row you are say after the create and save. Okay, I click here and so what happened. Yeah, you can choose like REST API. So you can build, then you can give all the detail. So I want to like what we can create these all things with help of this cloud formation. Yeah, we write the script and we run the script and we create whatever I am creating here with help of this UI. We can create same thing with help of this cloud formation. We don't require to go here and create them manually. Just write the script, the cloud formation, your API gateway up and up level here, whatever your base of the script you define. So if you want to create the method, you can use this script. with the script here. So you can define AWS API gateway method. You here put everything. What is the request ID, request model, everything you defined here, the value. So you can show the sample. I think this, they have sample. So the integration math, they also define the integration. What is the integration? Also what is the integration here. So after the create this API, I have to add some integration type with this API. Okay, so I create, so after the API create, we go inside that and we have other options to add methods, resource, and then we can deploy API. So here you I add user as a resource, and this is my method post. So you can see that I'm hitting this thing here. So I'm using post methods. I'm providing add user as resource, and this is my request user. Okay, body. When I post, so I'm sending data in body, and if we send the token in this authorization part, and send some value header part also if we need it. Okay, so here method request. Okay, when whatever this I'm sending a request, this is come here, and this is we can interrupt this request and we have modify the request before it's going to Lambda. So I will show that how Lambda look like in code. Okay, so here you see the request handler here. So my class, Lambda class, and here this is a request user. This is a response. We have defined two type, like request type and response type. So request type, whatever I have here, so it's mapped here. Is my request object, and yes, and I can. So now here I'll write the logic to save data in dynamodb, and also save the data in S3. Okay, so yes, I will upload this code on the Git. Okay, don't worry, I will update this code on Git. Let's see what happened. Not responding. Okay, so I build this code in, and I upload the jar file. Okay, so I create jar file for this Lambda code, and I create Lambda. Not I will explain this IAM. This is very important service, IAM. So in Lambda I will use this policy like user S3, dynamodb, and CloudWatch access. So I create the role in policy provide the full access dynamodb and S3. So basically this policy have full access to dynamodb and S3. So if we are use anywhere this policy, so that particular service can access dynamodb and S3 all things, all the object, and but it's not good approach. We cannot provide the full access. We can provide only specific access. Okay, so don't worry, this is only learning purpose. I am creating this video, that's why I am adding putting full access, so we not face any challenge when we are learning, or if you are creating if you implement these things in on account, so you not face any issue. So that's why I'm showing here full access. Okay, so now I create this Lambda. Okay, so how to create Lambda, here in the main window of this Lambda. So similar like so use the cloud formation, we also can create a lambda function. Okay, and we can deploy the lambda through the CI/CD. Here I am upload the jar file, but we don't require to upload jar. We can use the like cloud formation and CI/CD pipeline to build and deploy the lambda. So this UI part can create with help of the cloud formation, and the rest thing we and deploy the code through with help of CI/CD pipeline. Okay, so when you click create function, after that you have to define the function name and lots of things. Yeah, so that what happen if you click the function here. Yeah, you can here the sample, you can here you can like sketch, don't use any sample. You can define their like function name, lambda name basically, and you use the platform. I think currently only support Java 11, but now we have Java 14. So like you can use Java 8. I write the code in Java 8, so I use the Java 8 platform to deploy the lambda. So you can use like here the like deployment platform, like if you write the code in Python, you can use Python, and which language if you use any, there are lots of like Go, .NET, like Ruby, you can create similar like this. Okay, similar like that. So like you have, so I added 3 dependency, one for lambda in this lambda application, and the second one is the dynamodb, because I want to put data in dynamodb from this lambda function, and also add the S3. So because I also add data in S3. Okay, I create the file in S3, and yeah, so that's why I am using all this dependency. Yeah, okay, fine. So this is my man lambda class basically. Yeah, so here is the you give the lambda name and implement. This is the like predefined like handler, request handler. Here you pass your like request response. So whatever the request, whatever the response, you can define here. So yeah, you can context also, you can use context, but I'm not getting anything in context. I just use this user data and write this data, and I make this code very simple. So any beginner, if you have any beginner can like learn, make very complex, then it's very difficult to understand. Like if anyone never worked in lambda, they have some challenge to understand if we make more complex this code. So I make very simple. Maybe we can improve this code, but it's not needed here. Okay, so here we make connections like with the DynamoDB, and we are create one item. Yeah, here we write the some separate code getting from request, and we are creating here a new request. Okay, and I will put item. After that we write the file, same data on the file. So this I create one file user text. Yeah, I create this bucket. If bucket not exist, and if file not exist, I create the file also. So I use this code here. You can go very simple code here. I check first. I check the bucket exist or not. If it not exist, I create it, and I put this data. And if it exists, I check the object file exists or not. If file exists, then I will not create the file. I just yeah. Otherwise, I have to put object. So if the file is created, so I take the already exist content, then add a new content here. Yeah, and so put again the file. So basically, here appending the data in the file. Maybe it's not good, but I just for learning purpose I create this these things. Like we have one file appending data, and so maybe we create every day, create one file, next day we create the next file. So whatever data I have today, so we create this file next day. So we username, and here put the date, like current date, like today date. File name with the date. So we can like partition type, like every day we create the new file and write the data. Okay. So this is a user request, only 3 field, mail ID, mobile number. So sign up when we have like add user or like registration part. So mostly we have take mail ID, mobile number, or name. It's a common thing. That's why I added here. The user response I did. Yeah, we can. I create this jar file and I go and target here. I create this jar and I upload this jar. It's not okay. So we are discussing about Lambda. Okay, so your after creation your Lambda look like that. So you click here. Main things after you create the Lambda, the function name, the UI after that. So here, so if you go like API gateway, because I first I create Lambda. Okay, after that I create this API, and here in this API integration type is Lambda. So suppose I show the how can add integration. So you get, yeah, here like I'm not in this API, I not added any like integration type for like I want to show that how to. So I'm creating post API. That time I added this Lambda select. I put here this Lambda name, this Lambda. Yeah. So if you have 10 Lambda here, you can see the 10 Lambda you choose as per your required. So yeah. So I use Lambda in post. You can use also in get. So we define the some logic. This is the get request, post request. Based of that we by the logic. Yeah. So we can also use any like HTTP, yeah, integration type. So they have API, REST API, or they are backend process. There's Lambda function or HTTP or any AWS services, VPN link. So what as per your business way we can use anything. Here like I'll only show that how to create the things. I will create the separate video for all these services. Yeah. Now I am just explain only high level. So this API gateway associated with this Lambda. Okay. Yeah. So I saw the important part. So how to create the jar, you can upload jar from here function code, or you can pull the jar file from S3. First upload jar file on S3 and pull there. Okay. Just all this we can do through the cloud formation. We don't require like do UI. We should not use UI. We can do this through the script. Yeah, here we define this like my Lambda name class, main class name, where we have request this request handler request. So you can show that. Yeah, here this is, yeah. So this is my class user Lambda where I have this method. So this is man like very important method for Lambda. Here is the kick started here. So we have to define the trigger method name. Okay. So here define the class, the package name with class name, and after that method. Okay. And we can do one thing here also. Here like edit and here the role. You know, as I already discussed about this role. Like I provided to access. I added two full access for like S3 and dynamodb for this role. You can see this role and what I added. I already discussed this thing, but I again here can you show that? Yeah, this is this. Okay. So this roles like new user role, the name of the role that have the this policy name user s3 dynamodb, and so I create the policy. So this policy basically I provide dynamodb and s3 access, full access. Okay, if not provide this thing, the lambda my code want to access this dynamodb and s3. If not provide the role, that we cannot access this. He faced some security issue, access denied. Yeah, there's lots of issues. So if you are doing the first time, then you have very careful about this, like security bot. Otherwise, you never complete this process because you are fail every time due to the we get every time the access denied error. It's very difficult. Security is very important factor. Like in AWS services, you should know very well about the security services. Like manage the IAM. Like other also lots of security services we have, but this is very important service. So this is dynamodb. So this is basically key value is database and there's schemaless, there are no schema. So here we can see the 3 column. We can create new item and we can add like new field. The column automatically created and data is added. So we don't require like to define the schema and then we put the data. So based on the request, the schema automatically created and data is saved. So we don't require to more think about the schema. Like this is schemaless database basically. So whatever the request you have, based on that the schema is created. Okay. So this is my user table where I added data already. Yeah. So I think the 9 record. Okay. And here the S3. So I posting data in this bucket. Yeah. Creating the file. So whenever I hit this add user, the new user added this file. Okay. So till now we have discussed so till now we discussed like this client have API gateway, Lambda, dynamodb, S3, IAM, CloudWatch. Yeah. Now we will discuss about this email. First we also that I will hit this API, change the name. So this like we are hitting this API add user with this data. Okay, and once the request is completed, then data should be like saved in DynamoDB and S3 both. So I'll check this. I have debit 2. Yeah, so I open so here is no debit basically. Yeah, we have debit, 2 debit, but they have Gmail domain, other is Yahoo. Okay, we have 2 debit but different domain, it's not issue, and I added new debit 2. Okay, with Gmail domain, gmail.com. Okay, so I send this request. What happened? Let's open the database. I think pads. So I want to show one thing. Yeah, this is the reason where my database created. This is the US East Virginia and US East one. Okay, so there this is reason, yeah, US East region, the best East one. There's we have multiple region, but so check this request is completed or not. Yeah, request completed, 200 status is get. So I refresh this. Let's see. Yeah, we get debit 2. Okay, let's see this thing in file. Refresh. So like if why create a file, I will explain why I am putting the data dynamodb and the file parallel. I will explain this thing. Yes, debit. I appended this data in the file. Debit. Okay. So put the new request again, then again we append this data here, and also we save here. Yeah. So suppose we want to do some analysis like over this data. Okay. So we don't want to use the compute power of this DynamoDB service because this is dedicated for only my API. If you like, if we are for data analysis, if hit this DynamoDB, the compute power in we have like some compute where we can use for analysis. So that's why like even though this is very high scale, like you can scale very high level, but we should not use this. We have separate, like this will not use for analytics part. This is only application use, this DynamoDB. So application can, like whenever you build it, user application can get, post, delete and update. So there is lots of operation is done with this table. That's why 24/7, that's why we not touch this thing. I think that's why we can like post data some append S3, or we can do like we add this data in some queue like Kinesis or like in message queue, and through the message queue we read and then we create the file. This we can add one service, put lambda to like message queue, and then we put in S3. This can be do async call, but for learning purpose I just use put this dynamodb here, data and S3 separately. Yes, we can do like data validation, like whatever we have here, count, same count we have or not, we can do this thing, but not useful. Now this very we are come now with the like data analytics part, like how to like process this data to generate some reports, or maybe we get some insights from this file. Okay, and again back to some database table, like, or we can put again in like some storage, file storage. Okay, so here I use like what I'm doing, I read data from S3 user data and load in hdfs. Okay, I do some transformation, and so some ETL type I'm doing here. Again I read from hdfs and write back to S3. So from S3, so here you can say the S3 can use as a data lake process. Like we have raw data, then we have process data. Okay, so anyone can use this data whenever you want. To a different job we can create, and we can create like meaningful insights from this user file. Okay, it's very simple. But if we are done inside, we can use user file, like we have other like order file if we are working in like retail domain. So there's depend on the business, we can like do the analytics, we can join the different file data. So in Spark jobs, it depends. So what I'm doing, I'm read this 3 and write this data in hdfs. I write in Parquet file. I'm not using this text here, I use some other extension. This is the Parquet. Okay, I will show the Parquet file, how create a Parquet file, like show the jobs. Okay, that's all, and I will discuss this part. I've done this whole thing. Now we have this analytics, then we go visualization part. Okay, so this is my, here I create the cluster. So this is the Hadoop cluster I created. This EMR service is very good. Like if you can create cluster within 5 minutes. You don't spend too much time. You don't require any server, machines, anything. When I was start learning first time this Hadoop or Spark, that time I spent lots of time to set up this cluster. Like 4-5 years ago I start learning this thing like Spark and Hadoop, and okay, that time I have set up like this cluster on my local machine. I take too much time, like and now here is you can set up cluster within 5 minutes. Okay, this is my so you use this button create cluster and put the configuration, whatever configuration ask. You put this is my summary of my cluster. Okay, so this is the Spark, Zeppelin, and so basically this cluster have a do the EMR version like this 5.3. So EMR version 5.3 have application Spark 2.5 and Zeppelin install in all the machine. Basically, resource manager. So resource manager, what they use, so what I think yarn I used. They have yarn cluster. This data resource manager yarn. Okay, so here you see that this is my like the cluster zone is like US East 1B, and the subnet this, and they're running the master is running M3 Excel, and core is running 7 machine. The I request for 10, but it's not created because maybe I have account that is free. So that's why they're not providing 10 machines for me for create the data node. So this is a master node of my cluster. 7 is the data node. Okay, I will show these things. Here some warning. Forget this warning. I had some like security group for master have separate security group, slave have separate security group, master slave, like this. So I can show something here, like yes. Why taking time? I don't know. Why taking time? I don't know. I love this. Why? What's going on? Actually, I have downloaded some design. I have some. I take these images from Google. So explain like master and slave. Yeah. So EMR basically like create the Hadoop cluster. So we can install the Spark. So we can run the Spark jobs and like map readable job, or like high peak. We can run high peak script. Yeah. So the image, why not opening this? Taking time. Forget this. Okay. Now it's time to do some better thing. I love this. Actually, I love this part, like EMR. Like creating cluster is very easy. Explain this application user. So only one click on cluster ready, last step we completed. Yeah, waiting stage. Okay. So through inspection user interface, we retry what has happened. So here is this, that is a Spark history server showing the Spark. This is a resource manager. Yes, click this and what happened. So I show that like meanwhile I want to show something. Yeah, this is like I just click the create cluster and add put some configuration value. After that, so automate this 8 machine created for me by EMR. Just if you want to set up, this take too much time. I think only DevOps guy can set up these machines. Developer cannot because developer don't have too much knowledge about the set up the cluster. But what the AWS make this job very easy. Just click on create cluster button and put the setting your cluster up and running. So yes, so that which one is the which machine is slave, which machine. So you can see here, yeah, this is a slab machine. Okay, so you can note down, and here you can define. This is very important, inbound, outbound, because if access some URL, then you have to like provide some access specific port. The start when this cluster create, that time the port is not open. So have to check which port you want to access. You can open, and if not want to use, you can close this. So here this about the ec2. The ec2 machine, the slab is one slab is running on that ec2 machine. So all these like infrastructure. This is the storage device. So whatever we have here is like this is ec2, and everything is done by EMR here. We not done anything. I not done any things with these machines. They automatically created by EMR. That is great. Slave, all these slave. You can see the slave machines. Yeah, this is a slave machine. Slave machine, we can say data node. Yeah, simply, yeah, data node. Yeah, slave. Oh, this is my master. Yes, this master have this store. Okay. This is my master. So master node, we can say name node. Okay. And here we install the resource manager or master node. Okay, so there 7 is there we have total 8 machines. So 7 is slab, 1 is master. Okay. I didn't do it. I didn't done anything here. Like this automatic created for me. I just click here. I just click this cluster button. Yeah, and I put some configuration. After that, click one page open. You put the configuration how many node you want, how many master node want, how many name node, data node you want. You can put the configuration by the size. This is available for you. Yeah, it's very simple. Yeah, for at least learning purpose, anyone can use. So if you want to do some POC, you can use this cluster and do that. Yes, this is the cluster. So yeah, let's plan that how many applications running. You can see this. Yeah, it's the schedule, failed, everything's nodes. Yeah. So yes. Okay. I think this is yarn. Yarn is like manage the resources on. Yeah. This is So this is 5070 is master node. Okay. So master node, the 5070 they are running this port. Running this, you can see this UI. So if you open this machines where this is our master node, so our master node. So okay, and here this public DHL. So I'm accessing this. Okay. This. So 507070. If you put this URL and put this port, by default port is this page open. So he is showing about that is active, and this is detail of the master cluster. Basically they provide the cluster detail, what the memory size you use in the cluster, and how many nodes, how many live nodes there. Yeah, so here find the cluster detail. Okay, how many remaining and data nodes. So the overview of the cluster basically. This is the same data node we have. All the services running, no one down. So this is the detail of the data node. So how many data used, we are showing. Okay, the simple. You can open this URL if in master node. The here inbound you have like if you provide the access for this port. Open this inbound, outbound, and you provide the access for this port. Initially this not like this is port is not, you cannot access this. You have to like open this port in your ec2 machine for public. Yeah, here is like you can see the jobs 1808080 Spark jobs, running jobs, current jobs running in the Spark user lab. Yeah, Spark user. Okay, so now we open the codes that I write in notebook. So notebook basically like interface to write the code, like Spark Scala and Spark Python. You can use pyspark. So you open this Jupyter. lab. You write the code and you can run, and the code is deployed to the master. Submit the code will submit to the master node. Master node will post the code to the data nodes, and data node will run this code and we get the output. Okay. Here I already run this job. This is Spark Scala code here. You always, whenever if you write, I have some issue now, something like, if you like have like select writing code is in a Scala, then Spark Scala, then you have to select this Spark kernel. If you write the Python, then you have to write code in it's like you have to select this kernel pyspark. Okay, so we can so without this interface we can write code only. Yeah, so you have some issue down, some like session issue, because I will correct this and I will okay. Yeah, so I write the code in pyspark and Spark Scala. So this Python code is Scala code. Okay, so I have already run this code one time. So here you can see this, there's no debit to. Okay, the output there's no debit to. Okay, not debit to. So I can schedule this job like every 10 minutes or every 5 minutes to generate the reports. Okay, so it depends on the business. It's not okay. Okay, so I explain something before starting the job. Call the job. So here like we have like Hadoop cluster. So Hadoop cluster basically have two things like processing part and like storage and resource management. So resource management are done with help of the yarn, and storage we use this concept Hadoop file system. So and for processing we use the MapReduce. We can only write the code in Java. Use a Spark, we can write code in Python, Scala, and Java or SQL and R. So we have like in top of that Spark, Apache Spark core things, we have like streaming, Spark SQL library, and on top of this Hadoop processing part we have big hype. So now we can say that the Spark mlib, so mlib okay, Hive is similar to the Spark SQL, and pig it's not used. The pig is the scripting similar to, so Hive and pig the converted in the MapReduce job, and the MapReduce is processed the data. Okay, so similar here we write the Spark and the Spark SQL things is SQL convert to the like maybe the Python, Java or Scala, and that is run, then the code is process data. So we use Cassandra, like so Spark can read the data from Cassandra as base, Hadoop can read the data from HBase, because they are on top of the HBase is built on top of the hdfs. So okay, Cassandra not separate things, they not use any hdfs anything, they are Cassandra itself distributed. So Zookeeper is manage all things. So strong like this part also is like similar like Spark or Hadoop. So streaming, processing data. Okay, so three-man processing like Storm, Hadoop, MapReduce, and Spark, and other things may say like Apache Flink, that is also used for processing data. Okay, here like there are some like connector like processing direct data in the hdfs, the flow, Kafka. Okay, scoop, yeah, so reading the flat file is this flow, and streaming data with Kafka, and Scoop I think use read data from SQL or in database and post in the hdfs. Oh, this is the high level design, how like the cluster is the things. So we can install the things all in cluster. So currently we have only like Hadoop, MapReduce, Yarn, and hdfs and Spark. In my cluster we not install any other things like Pig, Mahout, or then we can use this library and we can run the code, but we not install Hive and Pig. Yeah. We not install anything for Storm or Solar. Cassandra we not install in my cluster. We can install all these things in my cluster, but I'm not done this. I just only main part of this like Hadoop and Spark. So here like something like there is Hadoop like Yarn basically resource management, yeah, how to like with job running, how to maintain the, so basically manage the resources. So not more, so we can create like the name node here, like secondary name node, active name node, standby name node, and here we have the multiple data nodes. Okay, so every data node has containers like jobs. Simply when we submit any job, they come running containers, container run and read the data. So whenever you post any job in master, the master create the container for this job handled by the app master, something like that. So slabs the master. So suppose we have 10 GB, save the 10 GB file in cluster. So it is distributed 1 GB. So is a 1 GB save in this data node and other GB save in other data node, and we can replicate it on this data. So whenever we want to fetch this, like processing this data, we run the different 10 jobs in 10 machines, and we after that processing we can combine data and we get. So it's very fast to done on everything in single machine. We can use the power of multiple machines. We can post the code to machine. Okay, a specific machine, data node machine, where data we can post the code in that data node. What we previously what we are doing traditional architecture, like we have big data server like SAN, NAS drive, and we are putting data for processing in the app server, but it's very difficult. Like we have large data and we are processing through this app server is very difficult. We face the slowness. I have like one organization I have worked there, a lot of big size data they are having SAN and NAS and try to process the data. Sometimes we face the slowness due to the I/O. Yeah, what we approach in Chain and Hadoop, like we are like program size is 3 MB, so we copy this all the program in 3 places, yeah, all the places where data have, and so this separate they as a data node is work. So the master is push this code and run the code, and output is come in some places. So we have like here we have like 3 processes running in different places and we reading data. Here we have multiple, like every data node have their own processing. So suppose we want to read the file, so the file is available in 10 places. Okay, so we go the all 10 places. So if we read one to the data for a user data available in the multiple nodes, we can read this and very fastly. And here we take time, or also like we get the exception out of memory, or maybe application crash or down, but they are never down crash, like because we have small data and we run the application on that small data. Here we have like large data set, we are running this application now. So how do we solve this issue? Hadoop architecture, yeah. So yeah, like hdfs architecture, how it is. So name node have the information of the files, how many replica we have. So name node is responsibility, like how many job will run, how like this where data is available, if any node down, So they redirect to the request for any other node. Like suppose this node down, the name node send the request for 3, copy the program 3 places to read the file, but this node is down, then name node is a resource manager. With the help of resource manager, we can switch the request to this node because we have replication of the data, so we can start reading from here. If it's node down or this node down, we can start reading this side because we have replication, we have rack base, so it's very distributed way we can read data. Okay. Now we go code. So here the Spark architecture. Yeah. So here driver, Spark context, we have cluster manager like YARN, and they have worker node like data node where we are posting our code. So the code is running like multiple nodes, same code, and we get the data and we can combine data. Okay, so the task manager handle the things, yeah, everything. So driver programming, so they are working like that. So okay, so here same thing like if I run this program. Okay, so suppose this file is currently this file is very small, so it's not like available in the multiple nodes. It's only one node, or so simply we will not run in the multiple program for that. So the single program can read this. If the file size is large and this is I saved in S3 and S3 saved this file in multiple places, then we can run the multiple job. So like so I read this file, and so we read the RDD format, then I convert in data frame, so we can use this. Yeah, we can sometimes transformation like I call this, yeah, this is Scala good. Yeah, I write this Parquet format. Yeah, this is my Parquet, and we override the content. We have whenever we get any so every time we are something like truncate and load data. So this is for reporting purpose, you know. Okay, so we read the whole file and write again. We can approach the incremental load. This is the different approach. We not follow here. We just learning purpose and so that how the job. So I ran this job. Yeah, I want to try to run this job. Yeah. Now, okay. So just start running now. So what is happening backend, like the Spark job created and submit to master submit this job to the node, data node. Okay, very data available. So okay, and after that they write this data, and so in the David 2 I added recently in my here in dynamodb in S3. Okay, and I get this in report in this Parquet file. So if you want to see that where is the Parquet file, so it's a 7 Hadoop cluster, so I can go the UI. Yeah, this is my master node. So through the master node we can see the data to the browser file. Yes, so we save the data inside the user. So this user.parquet. Yeah, I saved this data recently, like date check, yeah, time and date. So what it time is not is EST time, I think. What is this EST time? Well, so what is the node time? So I think that time is come here. Where is my cluster? So where the node is running, that time zone is upload. Yeah. Okay, so now I have write in data and file. I can see this file here. It's my Parquet file. I can open this. Yeah, this is here is success. So So if file is write successfully, they are commit their commit logs, something like that, and you can download here. They put the information, the real success file. So whenever we read this Parquet file, so I read this success log and check the which file is correct to read. Like, okay, maybe some file when you try to write here would fail. Like what? So here we do success. Which one is success? That is all the success data we can read. So if go. So yeah, this is my so okay. So this is our Parquet file. Yes, user Parquet. Oh my god, what I want to show that here again. Spark. So check this Spark job is yes, this latest new job. Yes. Lab station 15, and I can check now if what happened. Yes, yeah, there's my code. So here the edit and this Parquet file, because I added this new user. Here I am doing manually what we can do this job, and this is one. So this is Spark job when backends. Yeah, you click here, so you see that how it's going on. So if you go to more detail, so you can go this 756 is the you can check jobs, complete jobs. Okay, yes, so here in detail Parquet save. Yeah, this is submitted time, so we can check that recently file with somebody. Okay, so we have like stages. Yes, so here I want to show environment. What's the environment of this for the Spark? So Spark Python is set up 3 Java. So this is the setup of the cluster, like what the version of Spark and Java and Python and Scala have in my this cluster. So you can find everything, like what the master, like what the manager, like EMR. So you can see this. You can change this configuration when you write a job. So you can go here and you here add the code to enable security, or you can write the code like to override the property, anything what you want you can do here. Yeah, so here I'm not Spark uses Spark SQL, just use RDD, and you have RDD and data frame. I use the data frame API. Okay, we can use we can use like SQL or data frame API to work with the data frame. Data frame looks like the table format, like they have structured things like RDD is like unstructured. They are not like any form. They look like this the string format. So every line it is a string. Yeah. So whatever, not every line, the whatever they have, they put everything in as a string format in the RDD. One RDD have data in the string format. Now I can read RDD and split this. Okay, and then convert to data frame. So this format. Then I write this in Parquet file. So now I can run this. This is my analytics job basically. So here I'm going to do analytics, like I want to find out at how many like domain based count I want. Like how, like currently I have 3, mail is email is 4, redif 2. So now my just data is changed because I run this per job. Okay, I ran this job. Okay, and so that spark jobs change my this file. You can see this file. Yeah. Like suppose I schedule this job every 10 minutes. So when if any user is like use this user API, and that data is added in this user packet file, and that is used for reporting purpose or any other purpose back to application or somewhere. So now I want to run this and let's see what output is come. So I think what David 2 have. David 2 has Gmail, so Gmail count will increase. I think previously we have 4. Now check what is come. So the job is running, so you can see. Yes, the previously have Gmail count 4. Now it's 5. You can check also here because I'm writing the same code in pyspark. Yeah, so I run this. So I run this. Yeah, I run this code again. What happened? Look like. Spark jobs. I make some different file name. Here the extension py. So this raw data is same, but I created a different file from this raw data. So this is my raw data, like so whatever we're getting from application I'm adding here. Okay. After that we are doing some more transformations and edit this file created. Okay. Yes, it's running. So here you can see that the 7592 job is, you can see link left side is showing the application. Yeah, this is 7592. So you can Spark UI, you can open 7592 job. So here is the current is what the job is running. So you can check here. So current job what the running. Let's go. Complete applications. So 7592. How to know the job? Because I can have link. This link and you link URL showing this 7592. Here link URL showing. So here link showing 7592 jobs is running. Now I see that is David added. Okay. So suppose here there's Gmail 1 2. The Gmail domain is 5. 5 you should log in, like sign up, or we can say like we getting this data from some API that is like with Gmail domain. The 5 user have Gmail domain. So I run the report again. So I think the count is the 5. Okay. So the second job I run. You can write this code. Yeah. So you can like develop API gateway Lambda and use MyZar, and or you can write your code, or then you can like add the roles in Lambda and create a table in dynamodb, and yeah, you write the code to create the bucket and write the file in S3, and then you will launch the EMR cluster. Then you will start writing the code in Scala and Python as per your skill, and after that you can see the cluster and you can know ec2 how many machine is running a cluster, and you can see the this, after that you can see the logs. So this is log of my previous job. Here you can say yes, yeah. Market running, yeah, is showing like Java, RD, Scala. Yeah. So here the full log is available for the jobs, and you can execute some executors running for this job. Check, you can like the memory, like so how many memory use. Now it's active, so this is the active, yeah. So it's, here you can see the log, so you check your log, yeah. So you have the details, so you can see the SQL, if any SQL call here happen, then you can see that. So this is like simple, like you see your jobs and you understand what is going on in job. Yes, yeah. So now back to the notepad here. Okay, now this, yeah, this is pyspark job also completed, and there you can see the count. So now you can see the both job is similar thing, because I have similar data, because we have sources, because we have the same source, like users text. I'm not changing anything. Whatever source we have, we are running this job. So I'm getting this data in Python, and I'm getting same data in Scala. Okay. Same whatever doing in Scala, same thing I'm doing in Python. And write the Parquet file on it. So it's the depend on you. We can write this thing in Java also. Yeah, that's not a big deal. Okay, so we can use any language. It's depend on your requirement. You can write the code in pyspark. Yeah. But if you want to write the code Java, then you cannot use this interface. You can have, we have another option, like we create the jar, like similar like I'm creating jar for Lambda. So create one jar file, okay, and you can submit the jar file to the master node. Use the Spark submit, and or you can add the step in the cluster. Okay. So now is came to big things. That is this is the cluster, like this build part is complete. Now we go to analytics part again. So what happened if I run this query? Here is the 333. So if I run this query in Athena, my Athena is attached with so I create this database and table. This table is attached with this file. So I can something new, generate table DL. Yeah, this you can see, yeah, S3 file. So I write the data already at that place. So this report, I'm showing the report here. Also I write this data here. Okay, I'm just showing here, but this is for only for testing purpose. I'm just looking this data here, otherwise we don't need this thing, we don't require it. Okay, same thing here. So I'm loading, I'm writing, reading file, writing file. Or we can write the read data from, I guess, 3 Kafka, hdfs, database, FTP, MQ, Parquet, CSV, any data source we can write. there are 100 plus I think data source we can use with Spark, Cassandra, like MongoDB. We can read data from anywhere. Okay. So see that I write back the report data, this data in this file. Okay. So you can go this bucket and you can find S3. Where am I? S3. Yeah, this is my S3. So yes, so this is my bucket name where I am writing the report data, means analytics data. Yeah, this is my user domain, like count, domain name and count name. This file basically I want to show this data in report. So here I am on Athena, so I am pointing out this file. So whatever data is available this file, that should be come here. So previously I have domain count. Why they have too much count? Okay, so you have like this domain and count. Domain, okay. So I run this query again. I think some network issue, so this is showing, yeah, so count whatever we are writing in the file same that I see here. Yes, okay. Now I'm going to visualization part. So this is like automatically I'm creating database Athena. I don't know why they are create this database in data lake formation. I think this is only for create the data lake. Maybe they consider whatever I'm doing here, they are putting if we do anything. So this is like, so this is, I want to show that this is like AWS Glue. Internally there's some use some glue or AWS Glue like ETL type. Yes, you can see this catalog. So whenever you have query data, you can AWS, yeah, we have query data and S3 choose external data catalog, and there is two. So they create the two catalog. One is like AWS Glue, another is for data S3. So the backend, I think they use the Hive concept, like whatever Hive use, I think they use the same thing, but I don't know how internally they are reading the file and okay, but I think they use Hive concept. Okay, now we have like this data set and we have report start. So we had Gmail domain 5. Now currently we have like 432. This is I think Gmail. Okay, and I will refresh this. Should we auto refresh? Why not refresh? So quick site, like connect with like yes, now you can see this 532. So what happen here, like your Gmail have 5 count and like hdf2 and 3. This is my data that I'm showing, and like here you can see here, yeah, this is this data. So this is through the Athena I'm reading this data. Okay, so 1 second. So what I'm doing, so when I like this work, like when create this like how to create data set. So basically go, if you edit this current data set, I can show this. So I created data set in, yes, this is my data set. Yes, this is my data set. So how it's created, like view details, like, so I'm using like user domain table, schema user db, and this is the data source type of Athena. So whenever you create that, add, like suppose you want to add new data source, like here is no, like suppose starting. So this if you want a new data set, okay, so you can select option like in the quick side view where I want to select data, like Spark or Jira, anyway. That's very good. Like, so we have options, too much options to like read, like we have multiple source basically. So I'm using this Athena source create data set. Okay, and that's why my data set, this is my data set I created. Here's a symbol, this is the Athena symbol, yeah. Okay, so we can use this, yeah. We created multiple data sets. So this is my user domain data set. I use this data set to do the analysis, yeah. So here see this query is, I just refresh and the report is generated. I haven't done anything here. Like if you go visualization part, so I just refreshed. So okay, so I just where am I going? Yeah, this is my data analysis. I just refresh this tab and data is automatically loaded. Now again I test very quickly. So I test this whole architecture again. Yes, this thing again I will test. Yeah. I will submit some data quickly. Now add David 3. Okay, David 3. Now the Gmail count should be 6, and if everything going to correct, previously have 5. So we run the, if we automate the jobs, then we don't run the manually. Yes, have it check. So check the response. Data is, yeah, I think response we get data loaded. Now we can run. So here is the David 3, I think should come. And this output we have David 2 only. Now this new output should have David 3. So whenever I hit the API, so data is reached here or here. After that we run the jobs, Spark jobs, data read come here to here, and then here. So S3 to hdfs, S3 to hdfs, hdfs to S3, and then is the used for visualization. So I'm first step, I just hit the postman data reach there. Then I will run hit the job we can schedule at the job. Then data is move the S3 to hdfs and hdfs to S3 like that. So I will show that yes, level 3 is come out. Now we go to run this test. So here is my new data as per the analysis. The data is new data is loaded in this file. Okay, so you run this job. Okay, wait. So here is the Gmail is 5. I think this will be 6 once the job is completed. Same thing we can do with this run, like we have same code, but their file is different. This file I am not using for reporting purpose basically. Yeah, I'm writing this file in S3 file 4, writing this file in S3. Okay, so now it's 6. Yeah, so I can also, I run the both job and I get the count 6. So Gmail, I've checked the report. I don't run Athena anything. I just refresh. So the 5 should be 6. Yes, yeah, we get a 6 count. So I just click here and I can see this data in my dynamodb and S3 and S3 to can create the some reports, and that's a report visualizing. Yes, I create. I'm not expert in this visualization part, but I just take some help. Like it's very simple. Like you can like select any these things here. You can change your this layout here. Okay, not like big deal. So Gmail is 6 count and RF2 and yeah, this character. So any can like business team can look this data. They understand yes, Gmail domain. The 6 highest is Gmail and second is Yahoo and third is Rediff. So same thing we can do with other data set. This is a simple data set I have worked. So I can create separate video for API gateway and AWS Lambda, dynamodb S3 and this cluster. Today I just summarize how is like flow is going on, like for this is for learning purpose, like to understand the end-to-end process, how the process works, so you can scale this process and like in your business. This is very ideal with only one user API, single and this host, but in real-time project there are just thousands of API we have, and we have thousands of entity like user entity, order entity, like web payment. There's thousands like claim, data entry, like we have thousands of entity we have in real-time project. So it's not too easy. But single API we can develop same way. That's not too much different. But the combining the whole business is very difficult. In this here, like here we have do some high-level analytics, like you combine user data, order data, payment data, and other data we want to combine and join. So that time is very complex. Then we do some analytics, not analytics. We can back to in some DynamoDB or somewhere where other application can use this data after the analytics. So thank you my site, and please subscribe and like my video, and I will upload more video in future. Okay, thank you. It's my site.